Okay, shall I start now? Write the heading speed and velocity. The next heading is speed and velocity. Speed is being represented with the letter V and velocity will be represented with velocity bar. Okay. Generally in the previous classes we have already studied what is speed and what is velocity. Now, speed is nothing but distance traveled with respect to time. Similarly, velocity, displacement with respect to time. Okay. Now, let us try to understand the meaning. Now, consider body started from point A, reached to point B. Then one more path. Consider this is the another path. In the first path, this is your second path. Path 1 and path 2. Which one is considered as distance? Which one is considered as displacement? Path 1 is considered as your displacement and path 2 is your distance. Okay, whenever we are talking about whenever we are considering about displacement, then we will discuss about the velocity, and whenever we will consider about distance, then we will be considering about distance. First thing. Second thing, in the position vector, we already discussed that if a body is at point A whose coordinate is x1, y1 and reach to point B, x2, y2 coordinate, consider this as point B. Either the body is randomly moving like this, then the position vector will be represented in this direction and this delta r is your displacement. And first over here is your r1 and this one is your r2. In this one is also called as final and this one is also called as initial. Then displacement is also, velocity can also be written as r final minus r initial with respect to time. Okay. Now, if distance is scalar quantity or vector quantity? Scalar quantity. Displacement? Vector quantity. Displacement, velocity is associated with what? Displacement, velocity is associated with displacement and speed is associated with what? Distance. If speed is associated with distance, distance is a scalar quantity or a vector quantity? Scalar quantity. Displacement is a vector quantity or a scalar quantity? Vector quantity. That means, can I say that speed is scalar quantity? And what about velocity? Velocity is what? Vector. SI unit of the speed is meter per second. Velocity, its SI unit is also meter per second. Now what about the dimension formula? Is there any mass here? Length? Yes. Time? Yes. That means, can I write dimension formula? This one is m raised to 0, l raised to 1, t raised to minus 1. Similarly, the same is applicable for the velocity. So dimension formula for velocity is m raised to 0, l raised to 1, t raised to minus 1. Write in two different columns. First write the distance, then scalar quantity, SI unit, dimension formula. Similarly in the velocity column, write all those things. Write on first. Okay, shall I rub the board now? Distance can be positive, negative or 0. Is it true? No. Distance is either positive if the object is in motion, or it can be 0 if the body is at rest. Okay. Displacement can be positive, negative or 0. Yes. Similarly, on the other hand, speed is always positive. Okay. If the body is in motion, or it can be 0 if the body is at rest. Similarly, come to the velocity column, and can velocity be positive? Yes, as it is associated with displacement, velocity can be positive, negative or 0. So velocity can be positive, negative or 0. Okay, shall we move to the next point now? Point A, point B, object moved 10 meter and taken time 2 seconds. Speed, distance upon time. That means 10 upon 2, that is what? 5 meter per second. Similarly, velocity, displacement upon time, na? Displacement is how much? 10 meter. Time is what? 2 seconds. So can I say 10 upon 2? Again, this becomes 5 meter per second. Are yes or no? Yes. Can I say that in this example, velocity and speed both are equal? When this is happening, velocity and speed can be equal. Yes, they can be equal if the body is moving in a straight line. If the body is moving in a straight line, then and then only. If the body is moving in a straight line, then and then only, without changing the direction, that should be mentioned. Okay, for example, consider reach to point C. There is no B. Okay, here, and this distance be 100 meter, and consider this time taken is 5 seconds or 20 seconds. Whatever value you want to take, you can take. Okay, distance from A to B 100 meter, time 20 seconds, speed becomes 100 by 20, 5 seconds or 5 meter per second, velocity 100 by 20. Are yes or no? What I am trying to say, got my point? Unless and until they are changing the direction, then and then only speed and velocity changes. If the body is moving in a straight line, velocity and speed both will be equal. Got my point? Okay, one more example. Now, consider body started from point A, reached to point B, then returned back to point C, and from A to B, consider it is moved 100 meter. From B to C, it moved 50 meter. To travel 100 meter, consider it took 20 seconds, and to travel BC and 50 meter, consider take as 10 seconds. Okay. In reality, body traveled from A to B, then B to C. Now tell me the speed. Speed is nothing but distance upon time. What is the distance traveled by the body from A to B, then B to C? 100 plus 50, that is 150. Time taken by the body, 20 plus of 10, na? Are yes or no? 30. That means 5 meter per second. Similarly, tell me what is the velocity now? Yes. So velocity is nothing but displacement upon time, na? And displacement is how much? Yes, obviously 50. Yes, very good. So 50 upon time taken by the body, 30 seconds or 10 seconds? 30 seconds. Very good. 30. 5 by 3. Is there any difference between these two answers? Our speed is 5 meter per second. Our velocity is 5 by 3 meter per second. When this is happening? When body changes its direction. Okay. So, in this situation, can I say that velocity is not equal to this one? Are yes or no? Yes? Okay. Write on this. Okay. Next heading, write the next heading, average. Speed and average velocity. Speed is denoted by V average, and average velocity is represented V average with a bar. Okay. First we will discuss average speed, then we will move to average velocity. Okay. Now, what is average speed? Average, according to the average speed, it says that average speed is nothing but total distance traveled by the body in total time. For example, body started from point A, reached to point B, then traveled to point C, then finally stopped at D or moving, whatever it may be. A to B, body traveled 100 meters. then again it traveled 100 meter. Then C to D, consider body traveled 200 meter. Okay, A to B body took 10 seconds. Then over here B to C body took 20 seconds and C to D body took 10 seconds. Okay, if I want to ask you what is the distance, what is the velocity between A and B? Simple, yeah. Speed between A and B. Distance is how much? 100 time 10. That means, can I say 10 meter per second? And B to C, 5 meter per second. Then C to D, how much? 200 upon 10, that is 20. Okay. So, when body started from point A, reached to point D, in that we will be having 3 instances. In these 3 instances, first A to B body traveled with 10 meter per second. 10 meter per second here. Then B to C 5 meter per second. Then C to D we got 20 meter per second. But according to the average average speed, it says that total distance traveled by the body with respect to total time. What is the total time? 10, 20 and 10. That means 40 seconds. What is the total distance traveled by the body? 100, 100 and 200. That means 400. So 400 upon 40, that is equals to 10 meter per second. Now, what is this V average? What is the meaning of this? Can I say that if a body started from point A and is moving with a constant speed of 10 meter per second, then body can reach to point D traveling 400 meters, that to be in 440 seconds. So, can I also say that average speed does not tells you what is happening throughout the journey? What I am trying to say. Average speed, this 10 meter is telling you what is happening between A and B, B and C or C and D? No, nah. That's what I am saying. Average speed tells you that what will be happening if you move with that and you can travel this. For example, the best example is on the board. A to D. How much is the total distance? 400 meter. A to D, how much will be the time taken? 40 seconds. Yes or no? Without changing the speeds, that means 10, 5, 20, without changing or without having different velocities throughout the journey, if a person can move with a velocity of 10 meter per second, then the object can reach from point A to point D with same time. And can I also say that if a person is moving, can I also say that average speed does not tells you how many times the velocity is changing throughout the journey? Can I say that? Explain yourself. Okay. A and this is your B, body is moving with 10 meter per second and this velocity is constant. Similarly, radius is R, A and this is your B, body this time is moving like this in this direction and the body is moving with 10 meter per second and this is also constant. Tell me what is the average speed? Both cases, yes. Oral answers. Okay. If a body is moving with constant speed, either in any direction, in any form, then average speed will also be 10 meter per second in this case and will be the the same in this case. I got my point. Okay, next thing. A, this is B, and this is your C. A to B distance is given x1, A, B to C x2, time taken t1 here, time taken t2 here. Tell me V average. V average is what? Total distance upon total time. This can be written as total distance upon total time. Total distance is how much? x1 plus of x2 divided by t1 plus of t2 na? Are yes or no? Over. Similarly, next one. Consider body started from point A, B, C. This one is x1 and this one is your x2, v1. This is v2. Tell me V average here. Try this answer first. Okay, shall I? Do we have T? T1 and T2? No. That means, can I say velocity is nothing but distance upon time? Or time can be written as T, can be written as Vx. X upon V. Similarly, T1 can be written as x1 v1 and T2 can be written as x2 v2. Substituting T1 and T2 over here, what is average speed formula? X1 plus x2 divided by T1 plus T2. Are yes or no? X1 is x1 plus of x2 divided by T1. T1 can be written as x1 upon v1 plus of x2 upon v2. Shall I rub this side? Okay, special case for the next one. If x1 is equals to x2 is equals to x, then the same V average can be written as x plus of x divided by x plus v1 plus x upon v2. Can I write like this? Or can I take 2x x 1 upon v1 plus of 1 upon v2? Can I cancel these two? Can I take the LCM and move to the numerator? So 2 times of v1 v2 upon v1 plus v2. Write down fast. Okay. A, this is B, this is your C. Time taken T1, time taken T2. This is V1 and V2. V average. Come on, be quick. Okay. Shall I know? So V average is nothing but x1 plus of x2 divided by T1 plus of T2 na? And this can be written as, do we have x1? No. If we don't have the x1, so V can be written as x upon T, or x can be written as Vt. For x1, we can write v1 t1, and x2, we can write v2 t2. Substituting these values over here, then x1, v1 t1 plus of v2 t2 upon t1 plus of t2. Can I write like this? Okay. Or, if in this situation, if t1 is equals to t2 is equals to t, then can I take t common over here? So V average is equals to t taking common v1 plus of v2 upon t plus of t to t. Can I cancel these two? Or the final result will be V average can be written as v1 plus of v2 upon 2. Write down first. Okay. Write the next heading. Average velocity, and this is denoted by V average with a bar. Okay. Now, average velocity and average speed, sometimes they will be equal, sometimes they will be having some different values, and generally V average can be written as delta x upon delta t or it is nothing but r final minus of r initial upon delta d. Okay, that means point A having a coordinate x1 comma y1, and let this one be point 2 and y2. And can I say this one is your r1 and this one is your r2? This one will be your delta r na. Already we have discussed this many times. So delta r final initial, or you can say r2 will be the final one and r1 will be the initial one. Okay, now all the equation what we have discussed with the average speed are valid for average velocity. Okay, but we need to understand some different meaning of this. Shall I know? Write down first. I will rub the board immediately. Completed? Are completed. Shall I rub the board? Okay. Now, point A, point B, and point C. Body started from point A, then reached to point B. Then again from point B, body wants to change the direction. Okay, we will discuss this one, and then the next we will change the direction. For example, this one is 100 meter. This one is your 200 meter. Over here, body took 20 seconds. Over here, it took 10 seconds. What is V average? Total distance is how much? 300. Total time is 30. So 300 upon 30, that is nothing but how much? 10 meter per second. Okay, tell me V average. That is displacement upon time. Displacement and distance is same na, because body is not changing its direction. Both are in body is moving in a straight line only. So displacement is also 300 and time is obviously 30, and this also becomes 10 meter per second. Let us consider the other example over here. If body started from point A, reached point B, then moved to point C, and consider this as your point C, and from A to B, distance is your 200 meters, and B to C, your distance is what? 100 meters. To travel, it took 20 seconds. To travel this, it took 10 seconds. Tell me average speed and average velocity here in this case. So V average can be written as total distance traveled 200 plus 100, that is again 300, and time is what? 30, that is what? 10 meter per second. And what about average velocity this time? Average velocity, final position 100, initial position 0, and total time 10 or 30? 30, very good. Okay, so V average can be written as 100 upon 30, that is upon 10 by 3, 3.33 meter per second. Now, what is happening in this situation and what is happening in that situation? Can I say that in this situation, V average and V average, that means average velocity and average speed is equal in this situation? And over here, in this situation, can I say that V average is not equal to V average? Write the next heading. Instantaneous speed and instantaneous velocity. This one is represented by V instant and this one is represented by V instant. Okay, velocity is obviously vector, that's the reason vector notation. Okay, now chalk piece. Shall I? Now listen very carefully. First, I will tell you what is the meaning in reality. Okay. Now, instantaneous velocity or speed at time t is equal to average speed between time t to t plus of dt, where dt tends to 0. Okay. You will be finding this statement in many books. Instantaneous velocity at any time t or instantaneous speed at any time t is always equal to the average speed. Average speed between any two times. But to understand, first we need to understand the definition. Okay, and the definition of this one says that instantaneous velocity is or speed is nothing but speed at any instant of time. Instant means short interval or short time. Okay, but how much short? How much short? Let us try to understand now. Write down fast this one. Now, consider a body started from point A and reached to point B. Okay. Total distance from A to B is given. That is what? 100 kilometers. Let us find this in kilometers now. And body took 2 hours to reach point B and body is moving in this direction. As we all know that average speed does not tells you what are the things happening throughout the journey. We already discussed this. Maybe body at this point is moving with 20 meter per second. At this point 100 meter per second. Maybe this point body came to rest. Maybe this one over here 50 meter per second. Sorry, kilometers now. Okay. Maybe here 200. So on. Till here, any doubt? If I add all these and if I take the mean, do I get reach to mean? Average? No. Average tells you what is happening throughout the journey, or it tells you if you move to a constant velocity or a speed, you will be covering the same distance with same time. Yes or no? Okay. Now, if I calculate this average speed, first let us calculate the average speed. So V average is nothing but total distance upon total time, and that is 100 upon 2, that is 50 km per hour is your average velocity. This average velocity, that is 50 km per hour, is throughout the journey. Are yes or no? Now, for example, if someone asks me, what is the speed of the bike, car or the body? Consider body started at 12 o'clock. Obviously, it will reach to 2 o'clock now. Okay. Body will reach to 2 o'clock. Now, if I ask you at a time t, and time is given, at t is equals to 1 hour. and 0 seconds. Okay. To 1 hour, 1 minute, 0 seconds. And the person who is riding that bike, car, he said that he traveled to a distance of 1 kilometer between this time. That means in 1 minute, he traveled 1 kilometer. Then what will be the speed? Then we can calculate that. So V average, why I am writing V average? V average, we are calculating only for time 1 minute. So in 1 minute, body traveled how much? 1 kilometer. So total distance in 1 minute, that is 1 kilometer divided by time is 1 upon 60. Can I write like this? Yes. Then can I say that body is moving at 60 kilometer per hour in what time and what time? 1 hour and 1 minute. That means in 1 minute, in that 1 minute, body is traveling with what? 60 kilometer per hour. Now, let us try to understand. So, here at 1 o'clock, 00 second, and 1 o'clock, 1 minute. Body traveled how much? From here to here, body is traveling 60 kilometer per hour. Na? That distance is 1 kilometer. And to travel from here to here, it took how much? 1 minute. Then, in 1 kilometer, what is the speed at 0.2 kilometer? Or what is the speed at half? Can we calculate that? That means we need to decrease the time. Yes or no? We need to decrease the time to reach exactly precise value of what is the velocity at 0.5 kilometer, or let's say 0.3. Consider this as 0.3 kilometer. That means 30 meters. Yes or no? Okay. Let us find what is the value of speed at 30 meters. So, at time t, given time is 1 hour, 0 minute, 1 seconds to 0 and 2, 1 hour, 0 minute and 1 second. Already considered we traveled how much? In this time instant, we traveled 30 meters. So can we calculate V average? So V average is nothing but 30 meters, and we have to convert that in kilometers. That means 10 to the power of 3 upon time is what? 16 to 60 na? So 1 upon 3600. So this can be calculated. Already 102, 2020. 36 goes over here. 36 into 3. 108. So 108 kilometer per hour. Yes or no? Okay. Now let us try to understand what is happening. So between time 1 hour 0 minute 0 second to 1 hour 0 minute and 1 second, body traveled to a distance of 30 meter with the speed of 108 kilometer per hour, and body took how much time? 1 second. Are we moving towards precise values? Yes or no? Can we further decrease the values? Yes, we can. Okay. Now, in the beginning, we have calculated what is the average velocity throughout the journey. Okay, and we got 50 kilometer per hour. That means in every hour, body is traveling how much? 50 kilometers. Then we calculated how much the body is traveling in 1 minute, and in 1 minute body has been traveling. So in 1 minute body has been traveling to a speed of 60 kilometer per hour. Then we calculated what? For 1 second. In 1 second body can be considered that body traveling for 30 meters. If someone asks you what is the velocity when you reach to 10 meters, or what you reach to 0.1 meter. Okay, that means if in 1 second I am traveling 30 meters, obviously in 0.1 meter can be traveled in milliseconds. Let us try to find that also. Okay, now, so 1 minute and 002, 1 hour 00 minute and millisecond. So millisecond is written as 0.0001. Okay, we are talking about this time. Now, let us say we considered 1 meter. Na? So 0.1 meter has been traveled in how much time? 1 millisecond. Okay, now average speed निकालेंगे. V average can be written as how much distance traveled by body? 0.1 into 10 to the power of minus 3, and millisecond means 1 upon, in 1 hour 3600 seconds, and in each second 1000 milliseconds are there. That means I have to multiply this by 1000. Okay, and this can be written as 10 to the power of minus 4, 10 to the power of minus 4, and this goes to the numerator. That means 1, 2, 3, 4. That means V average is 360 kilometer per hour. Okay, what does this data tells you? As we decrease the time period, from the average velocity or average speed, we are moving towards instantaneous velocity. As we decrease the time, and we are decreasing the time in what? We are calculated the average. From that average, we took a smaller and smaller and smaller time, and we are converting average velocity into instantaneous velocity by decreasing the time. Got my point? That's the reason you found that. First complete this one. Write on first. Okay, in the beginning I written like this: instantaneous speed at time t is nothing but your average speed between time t to t plus of dt, where dt tends to 0. Now, check this. The instantaneous speed at any time t is nothing but average speed between time t to t plus of dt, and this dt is very, very small. Ardhamainda? Okay. Now, how to write this mathematically? That means V instantaneous, either speed or velocity, whatever it may be, everything remains same for this one. Only the direction changes. Okay, now V instantaneous is equals to, can I write limit delta t tends to 0? Can I? Or can I also write like this? V instantaneous is nothing but dx upon dt. This is the real meaning of instantaneous velocity. Write down first. Okay, now consider x-axis, y-axis and z-axis, and body is moving like this randomly. Can I say at this point tangent will provide you the direction of velocity? At this point tangent will provide you the direction, and at this point tangents will provide you the direction. Okay, consider this body is covering in x-axis, y-axis as well as z-axis, in all three axes. Okay, now what is instantaneous velocity? Just we found instantaneous velocity can be written as dx upon dt na. Are yes or no? And this x can be written as in terms of dr. If the body is traveling in all three axes, then position na. Okay, now this can also be written as xi cap plus yj cap plus zk cap dt. Can I write like this? Can I separate these three? Or V instantaneous can be written as dx upon dt, dy upon dt, and dz upon dt. Then this can be written as, these are nothing but the velocities or the speeds. So velocity along x-axis plus velocity on y-axis plus velocity on z-axis. Right on. Before writing, just listen to me. For example, body A reached to body B, and body is moving with 10 meter per second, and this is constant. Okay, body is moving with 10 meter per second, constant velocity. Now tell me V average. Yes, very good. Just before we learned that if a body is moving with a constant velocity, average will remains the same. Nah? So over here, V average is 10 meter per second. Can I also say that this is nothing but velocity of average also? Why? Because body is moving in a straight line now. Can I say that? Okay. Can I also say that at any instant of time, if the body is moving with constant velocity, can I say that instantaneous velocity is also equal to average velocity at any instant? Yes. So this can also be written as V instant. When this is applicable? When the object is moving with constant velocity. Got my point? And we already learned that V average, yani average velocity, is always not equal to average speed. We already discussed this also, na? Okay. Okay. Now, in today's class, we have completed already distance, displacement, and we have completed few numericals on that. And we discussed the theoretical part of speed and velocity. Okay. By tomorrow, we will discuss what? The numericals on speed, velocity, average velocity, then instantaneous speed and instantaneous velocity. But one more thing, instantaneous velocity and instantaneous speed can also be changing. Let us try to understand this by one more example. For example, if a body is moving in a circular path, in straight line path, just we found that if a body is moving at a constant speed, then instantaneous speed, instantaneous velocity, average speed, average velocity, all are equal to 10 meter per second. Okay. Now, similarly, if body is moving in a straight line, either it is moving with variable velocities, non-uniform velocities, uniform velocities, whatever it may be. If at this point, if I found that velocity of that object is 10 meter per second, at this instant, at t is equals to, let's say, 4 seconds. Okay, at t is equals to 4 seconds, I found the velocity of the particle is 10 meter per second, and this time the body is moving in a straight line. If the body is moving in a straight line, at this point, instantaneous speed and instantaneous velocity all will be same. But the same thing is not applicable in a circular motion. Let us try to understand. Consider the body is moving in a clockwise direction at this point. Okay, what I found is at this point, velocity of the body is 20 meter per second. Velocity of the body is 20 meter per second. Okay, now if I am saying at this instant the velocity of the body is 20 meter per second, what is instantaneous speed? Then I can say instantaneous speed is nothing but 20 meter per second. Okay, but when I am saying V instantaneous 20 meter per second downwards. Why? Because at this point, direction of the velocity is in the downward direction. So can I say that V instantaneous is equals to V instantaneous? Always? No. But in terms of magnitude, they are equal. But in terms of direction, they are always equal? No. Sometimes they are equal, sometimes they are not equal. Ardhamainda till here? Okay, concept is clear. Thank you. Okay. Now, by tomorrow, be prepared with this topic. We are going to discuss the numericals on this one. Okay.